Tailscale adds this extra layer that actually re-implements the internetwork layer that was supposed to be layer 3 of the OSI stack. Now, in your Tailscale universe, you can reach every computer in the world, regardless of its physical location, right? Without worrying about firewalls, without worrying about port forwarding and so on, which is what the layer 3 was supposed to do.
Welcome to another episode of the Cloud Gambit. If you're watching the video, you may realize that my usual co-host, partner in crime, Yvonne Sharp, has been hot swapped with none other than Ethan Banks, just like a hard drive, for this episode. So, thanks for joining in on this recording, Ethan, in such late notice.
Yeah, thanks for the invitation, William. And you had said, "Hey, you got time to sub in for Yvonne?" I'm like, "Yes. What are we talking about? We're talking at Avery over at Tailscale. Yes, I very definitely have time. So I'm very keen for this conversation."
Awesome. And so, yeah, Avery with us today. None other than Avery Pennarun, co-founder and CEO of Tailscale. I'm sure many of you have heard of Tailscale out there. How are you doing on this fine day, Avery?
I am doing great. And I just want to say, Ethan, I love your background. It looks like you're in a sort of a padded cell, which my background is often accused of being. This is the infamous bed. This was rated 1 out of 10 by my Zoom room on Twitter at any point.
You're catching me in the midst of a studio transition. I bought these 3D tiles and I got colored lights and other stuff that's happening, but it's only half built.
Sure. But behind my camera, beautiful view and everything too. I promise. The door does open behind me. I'm not permanently locked in here, supposedly.
A minute.
We always tell the stories we need to tell in order to feel okay about ourselves.
So I guess getting into the serious, well, not serious, but, honestly, I'd love to learn more, just kind of reading up on your background and being honestly a longtime user of Tailscale. I'd love to learn about just kind of what makes you tick. Your career seems to have, just going back and reading a lot, it seems to have a trend of solving, sort of like, maybe like personal problems at like a truly dynamic and dramatic scale. Really encapsulated around taking these, complicated problems and simplifying them to the point where common, everyday folks, non-technical individuals can use and consume your work, which is, to me, that's the golden standard of technology. If you can make something that, grandma can use, which grandma can definitely use Tailscale. That's how easy it is. It's a huge testament to your work. But do you want to take the audience kind of through your background and when did you start, all the way back to when did you start getting interested in technology in general? And how did it kind of like morph and transform into where you are today?
Well, just to be clear, so far I've not succeeded in solving any of my personal problems. But I have chased around in my career a lot of my personal pet peeves that I would be happy to share with anybody willing to listen to my rants. And so it all comes from that in the end. So I think, back in my youth, back when I was in high school, we got our first dial-up internet connection from the local Freenet, which was the first internet provider in Thunder Bay where I grew up. And the Freenet was co-hosted by the university. And so my sister had a dial-up account at the university that she had borrowed from somebody else who was actually a university student. And she was using that to use IRC all the time. And I would use the Freenet connection that would I was volunteering, therefore I got an internet connection. But unfortunately, we only had one modem. And so at some point, I learned how to network like our old 386 computer and our 486 computer together via, it was initially a serial line IP connection, eventually got upgraded to a parallel line IP connection, for those of you who remember PLIP. And then there was this program called Term that would let you multiplex over a modem connection so you could both use it at the same time. And so I would do my internet stuff, she would do her IRC stuff, and we were both reasonably happy. Unfortunately, at some point, we both, got accused of accidentally hacking into the university network, which was not actually a thing that happened, but somebody hacked into it. And because I was looking into what the explosions were all about, there was a few interesting things in my bash history. I made it look like I had been hacking them to things. And therefore we got kicked out of the university. And that's when I moved to my first actual job, which was at the first commercial internet provider in Thunder Bay. Still a high school student. I didn't have my driver's license yet. I had to my dad drop me off at work. But we went there and I helped them set up their mail server, news server, web servers, build their billing system, stuff like that. And it was, they did pay me a certain monthly fee or hourly fee, but it was also like the most important part was I got unlimited internet access, which I heavily used.
Avery, did you have a collection of Frack magazine text files somewhere?
Well, I had to get the internet connection just so that I could download anything. So I never really got much into Frack magazine. I did download Linux for the first time over dial-up. Actually, the first time was over dial-up on a FidoNet BBS. So you actually had to send like an email to a thing that would download something from an FTP site and then split it into 10,000 pieces and then send it to you over FidoNet mail, which is how I got Linux for the first time. And I didn't have to pay any long distance. Because some sucker who ran the BBS paid all the long distance for FidoNet to exchange this information, which as a student at the time, I like vaguely understood, but didn't really understand that I was like kind of grossly misusing the service they provided. But they were actually really friendly about it. They're like, oh, wow, I didn't know you could do that. That's pretty cool. Maybe I can have a copy of these things as well.
That is the story of the early internet. I didn't know you could do that. I got a lot of consulting jobs to fix things. I didn't know my mail server could be used as a relay for spammers, for example. Yeah.
Yeah. Well, yeah, absolutely. And they all could back in the day, right?
Mm-hmm. Sure could.
And it was so exciting, this feeling when I got on the real internet, as opposed to this like, download by email internet, that we could like just ping any computer in the world or telnet to any computer in the world or FTP to any computer in the world. It was a direct connection, right? And of course, the firewalls are kind of unheard of at the time. It was just a matter of, did you have a username and password? Did you log into FTP as anonymous and get access to all the stuff that they had posted, right? It was so neat. And when you think about how that is possible, is like everyone was used to like phone lines and you'd have to dial a phone line. It would take a while and eventually someone might answer on the other side versus like telnet and like instantaneous. I remember
there was even an early... there was even an early anti-firewall kind of persona where it's like, nah, if you make your box secure, you don't need a firewall. What's that for? It's stupid.
Yeah, well, those people are still around today. I think they call it zero trust. But at one point, my grade 12 physics teacher asked me, "Is like, Avery, I heard you're into the internet. You need to tell me this. So like every continent at least has a different standard for plugging in electrical stuff. How did they get everybody in the entire world to agree on a single standard for every computer to be able to talk to every other computer? What did they do? How did anybody get that level of coordination when they couldn't? And this is complicated. This is data. There's all this stuff going on as opposed to like electrical power. How did they do it? And I stopped. I'm like, you know what? I have absolutely no idea. I have no idea how they did that. That's a really interesting question. And it bothered me for years. Now I understand, but it took me a long time to figure out how is that even possible.
So one thing and I know we have so many topics that we want to cover. We're probably not going to get to all of them, but I wanted to read just a quote. So I was on a previous episode, I had Yvonne Pepelnyak on, who's a pretty big voice in the network industry. And we pretty much did a commercial for Tailscale for like a few minutes. He brought it up and I wanted to, hold on, I got one of the quotes that he had up here in my notes. Hold on a second. I want to read it.
So the challenge for this call is to make it less of an ad for Tailscale than the one you already had.
I don't know if we can do that. That might be too hard. So Yvonne went on to say, on the other hand, I can't do his voice, but you have startups like Tailscale. They do one thing. It's a well-orchestrated VPN. They don't try to sell you document review or AI or, I don't know, incident response. They are a VPN company. Whatever they add, it's a tiny feature that allows you to use their VPN better. But it's still a feature to use the VPN better. It's not, some crazy outlandish stuff because the customer wanted to have two products for the price of one and everyone loves them because their stuff just works. It's a simple product that solves a simple problem. It happens to be a problem that everyone has. And so we all love them. The moment I finally figured out that I should try out Tailscale, I'm not even thinking about any other VPN. Now, I got to say, I didn't bring up Tailscale. I didn't even know we were going to talk about it on that conversation.
Wow, that's a weird monologue for him to just launch into.
Yeah, out of nowhere. But it's kind of like to the testament of, Vaughn saying that, it's kind of rare that, networking is just complex. Whenever there's in my past, whenever there's a big problem that's like holding up a project or there's some performance issue, sometimes it's other stuff. Sometimes there's app issues, but, a lot of times there's something going on in the network somewhere. It could be BGP, it could be DNS, but there's a lot of complexity. Things are really hard to upgrade. Things are, typically pretty hard to adopt and use and migrate. But, it's just rare in 2025 that you have something that, and to kind of go back to, a little more reading I was doing on Tailscale about minimizing operational costs that can kind of get, passed on to customers, and in the form of what is for Tailscale, this amazing free tier that I've been gladly consuming for a while now. So can you just kind of talk about the philosophy behind that? Like that, word of mouth, like, hey, let's create something so simple. Let's put out a free tier that's really good. And, that's kind of a marketing strategy. I love that philosophy, but it's a very rare philosophy, in 2025, but I'd love to hear more about that.
All right. Well, I guess I'm going to have to preface this with my career can be pretty accurately described as a series of walking down the street and then smashing headlong into a wall and then turning a different direction and smashing into another wall and so on. And then tripping over my own feet and going flying and then landing in a pile of gold. So none of that was originally the plan. I would say to quickly summarize the original idea for Tailscale, we had this thought that the name Tailscale comes from the opposite of internet scale in the sense that software companies everywhere, especially at the time, but still now, we're over designing everything. We need everything to be scalable just in case it grows to 1 billion users. And the truth is, most things most people develop will never grow to 1 billion users. And that's perfectly okay. Even people who work at companies whose product grew to 1 billion users, most of the stuff they work on doesn't need to go to 1 billion users. What about a dashboard you made for your team that's showing the current status of some production system or the build results or whatever? None of that ever needs to scale. And yet it's still using the same infrastructure as all this stuff that is going to need to scale. So what we thought is who's underserved? All the people making all those little things, which is everybody, including the people also making big things. How do we make it easier to make small things? And so we took this example of a dashboard. I want to launch a dashboard for my team. Let's figure out all the things that makes that annoying, right? And there's a list of 100 things. And then we sorted it by pain level, and we talked to customers and we went through and people gave us feedback, and the number 1 and number 2 answers were connectivity, which is getting the people on my team the ability to access the dashboard, and security, getting the people not on my team not the ability to access the dashboard. And then there were 98 other things. And then we were okay, let's go try to solve number 1 and 2 and see what we can do. And we threw together this VPN thingy. It's just okay, it's got identity, it ties into your identity system. And then we sort of to skip forward a few steps, it turned out that our solution to that problem is something like a $30 to $50 billion a year market, which is corporate VPNs. And corporate VPNs, they have a few things in common. One of them is that every company above a certain size has one. Everybody hates theirs, right? Everybody has a budget for it, and everybody's willing to consider replacing it with something that they will hate less, right? And so it's wow, that is a very, very big market for a very, very boring product that we found ourselves in completely by accident without having done that research up front. But the interest in this thing was much higher and faster than we expected. So Tailscale does eliminate a lot of the pain and suffering of setting up your own dashboard. We never got to the other 98 things on that list. If we ever got to them, it would be more like what you described. Oh, they launched another thing. Oh, they launched another thing. Oh, they launched another thing. Now we solved 98 problems. What we did instead is solve the top 2, and the market was so huge, we've never had time to do anything else. So there's an element of just being forced into it. And then later on, as we can retcon our strategy and say oh, well, this must have been the plan all along. Well, Tailscale, the best analogy I have for it is it's basically the new TCP/IP, right? In the sense that IPv6 was supposed to be the new IP layer, and it never finished rolling out 25 or 30 years after it was braided. And there's reasons it never finished rolling out. And I've spent a lot of time studying the reasons it never finished rolling out, because I'm sometimes characterized as hating IPv6. I don't hate IPv6. I'm really disappointed in IPv6 because it should be here. It should have solved the problems it was supposed to solve. And to this day, I have never once benefited from IPv6. And that makes me really sad. I should be able to benefit from IPv6, but it's not rolled out enough for me to even get an IPv6 connection most of the time. Right?
No, they
Anyway.
tried to fix too many problems. That the addressing scheme was not backwards compatible with IPv4, I think for me was the thing that just made it too hard to transition, let alone all the other changes they baked
the
in.
Python 3 of networking systems. Anyway, so someone had to fix that. It's like, look, it's been 30 years. We're still using IPv4. All the problems they set out to fix with IPv6 are still problems. But also we have 30 more years of problems that are new that even if you rolled out IPv6 wouldn't be solved, right? It's like, okay, you need a new thing, right? So we ended up building the new thing. And the new thing is like, if you compare it to TCP IP, well, you don't need to keep adding features to TCP IP for it to spread eventually to every computer on the whole world, right? It just needs to be TCP IP. It needs to be very high quality. It needs to recover from anything, right? It needs to be small. It needs to be simple. It needs to be available. It needs to run on every kind of device there is. It needs to be trustworthy, etc. And it needs to have a deployment strategy, unlike IPv6, right? And then people can build on top of it, right? And that is sort of the model of Tailscale that we have going forward. Is like, we don't need to build all that stuff. We just need to give you the basic platform.
Just to be clear, Tailscale is not a brand new addressing scheme or protocol as such. You guys took the traditional TCP/IP that we've got and built VPN with lots of operational work and governance around it, and the security piece is what it's WireGuard, right?
Yeah. Okay. So yeah, this is. Well, I'm happy to describe this in as much technical detail as you like, but the way I think of it, intellectual or like abstractly, is Tailscale is actually an extra layer in the OSI stack that's doing what layer 3 was supposed to be doing, but didn't, right? And of course, the way it works is it's a tunnel. So it's actually an extra copy of the IP protocol on top of the IP protocol that's already there, right? So did we invent a new protocol? Not really, but we did add a layer to the stack. The reason we need that layer in the stack is something I mentioned earlier, which is like, once upon a time, you could telnet to any computer in the world and just get there, right? Well, because IPv4 is something we got stuck with, IPv6 never got rolled out. Now there's like simple technical reasons you can't telnet to every device in the world, which is that they can't all have unique addresses. There's also more advanced reasons: firewalls, identity, security, worms, like NATs, everything else, right? But fundamentally, it's like, no matter if you could make all the security questions go away, you still couldn't reach every computer in the world because there's not enough addresses. Tailscale adds this extra layer that actually re-implements the internetwork layer that was supposed to be layer 3 of the OSI stack. Now, in your Tailscale universe, you can reach every computer in the world, regardless of its physical location, right? Without worrying about firewalls, without worrying about port forwarding and so on, which is what the layer 3 was supposed to do, right? But IPv4 is so old that it is now declined in its ability to serve that role. It's basically layer 2 now, which is why you find people like giving up on IP routing in big data centers, and they just use like whatever, I'll route by MAC address and do a giant software defined switch, right? Because like it's the only way to do it, because IP failed at its job. So we're the new thing doing IP's job. And if Tailscale just does the job of IP the way it was supposed to be, we'll have succeeded. Now, of course, to do that nowadays, you have to have security and identity and stuff built in, because you can't actually just have everybody in the world connect to everybody in the world, or there's going to be security problems. So we've had to do all this modern stuff that IPv6 also didn't solve, that has emerged over the last 30 years.
It's really, the way you think about it is fascinating. And William, I don't want to hijack your show because we could go down a whole other rabbit hole here, but Avery, just your description of layers and how you're thinking about the layers and the things that you've baked in, of necessity, right? You have to use what's out there that everybody can forward those packets around. You got to assume that that's a requirement, but then to have the tunneling layer that bakes in all these other features that aren't there with V4 and or aren't there with V6 is just a really interesting way to think about it. And I haven't been exposed to this way to think about VPN and the way you're going after it, and that is fascinating. And I need more time to think about it to know if I have an opinion, but that is really cool.
Okay. I'm just gonna, while we're here, I'm gonna give you the cherry on top. Tailscale is the deployment strategy for IPv6 that can actually make it finally be successful, and it works for two reasons. One, even if you don't have an internet connection with IPv6, which would require the client, the server, and every router in between to be on IPv6, you can still make your tailnet use IPv6. Every tailnet is fully IPv6 supported, regardless of the substrate it's running on top of. And also, Tailscale will try both IPv4 and IPv6 routes between every pair of nodes. So if your IPv4 link goes down and your IPv6 link is still up, you can connect to every node in your tailnet still, right? And we've had customers who are like, my website went down. I tried to SSH into it. It didn't work. I SSH'd in over Tailnet and it did work. And it took me like half an hour to figure out what was going on. And it turned out Tailscale was just happy to use my IPv6 link of where
Happy as in happy eyeballs? Was it that methodology?
Eyeballs, it's not exactly.
That's more web thing, but yeah.
So yeah, well, I mean, oh boy, and how deep do your red listeners like to go on this stuff? Because I could go on forever.
You tell me, Williams.
All right,
It's a mix.
Happy eyeballs is what web browsers use. So it has this specific built-in preference. I'm going to try IPv6 and IPv4 at the same time. If v6 is available and is more than or I think less than 50 milliseconds or something slower than IPv4, I'm going to prefer IPv6. Tailscale is a little more agnostic. And it's just, I'm going to try everything that I can try. And whichever one works best, I'm going to use that. And I'm going to do it all at the same time. And so IPv6, IPv4, multiple hardware links, relays, other kinds of relays, direct connections. I'm just going to blast it all and see what comes through. And the stuff that comes through, I'm just going to stick to that. So you get this, if any of those things work, you get connectivity. Right. So all kinds of interesting stuff that sort of breaks at the regular internet layer gets fixed by Tailscale layer 3. And if you remember the ancient history of the internet, it was designed by the Department of Defense because they wanted to deal with a situation where literally areas could be nuked and stuff. And you wanted to be able to continue connecting. IPv4 failed to didn't succeed at that because your IP address was tied to your physical connection, which was tied to your physical internet link. So if you had multiple links, you had multiple addresses and the whole thing fell apart. Right. With Tailscale on top, it puts the pieces back together again. All those multiple addresses on the physical layer come down to a single address inside your tailnet, which we will figure out how to route through all kinds of nonsense.
This has just given me, so I'm going to go down a few rabbit holes after this conversation. I know that. This has been fascinating. I think you mentioned WireGuard, and that just kind of, just shooting from the hip here, but I think WireGuard launched not too long before Tailscale, right? I think it was 2017 or something. And did Tailscale launch in 2018 or 2019?
We were founded in 2019. We kind of launched right at the end of 2019. I can't remember how old WireGuard was at the time, 2 or 3 years old. So I can't remember if it was 2016 or 2015 or something like that. But yeah, we do use WireGuard. Tailscale is divided into what I call the control plane and then the data plane. WireGuard is the data plane for Tailscale in the sense of actually delivering packets, encrypting them, and every packet has an identity associated because it has an encryption key associated. So that part works really well. We started out as just basically a key generator for WireGuard. And so it led me to my joke is people on Hacker News, of course, the first time they hear about Tailscale is whatever, I could do that in a weekend. It's just WireGuard. Yeah, well, guess what? I did it in the weekend too. And then we've been debugging it for the subsequent 6 years or so. And the reason for that is the control plane. The control plane is how you connect all the pieces together, decide what the security is, connect those keys into an identity system, build firewall policies on top of the identity system, and so on. But yeah, WireGuard is at the root of Tailscale, and it's data plane, and it's what we use today. It's a very good replacement of the data plane of a VPN protocol.
So did you look at, or did you try, did you have experience or did you try using OpenVPN or IPsec or anything else out there before you landed on WireGuard? And
Well, this is where, your people not watching the video will not realize perhaps how old I am. I'm pretty old now, and I feel even older on the inside. Let's see. I've used OpenVPN. I've used IPsec. I used a thing called PPTP, which Microsoft was pushing back in the Windows 95 days. Yeah. L2TP. I wrote my own. My first VPN protocol I wrote while in university in 1997. I called it Tunnel Vision, which, if we can just stop for a second to acknowledge the pun, it's a pretty great pun. that I was not very good. I rolled my own encryption. Don't do that. So many mistakes, but nevertheless, it was already a mesh VPN. It just like I was on the track already, and that eventually ended up in the product for my first startup, which I also founded with my roommate while I was in university. That was called Net Integration Technologies. We made an operating system called Nidix, goes a user-friendly Linux system that goes onto an appliance that you could put in your small business. And at the time, user-friendly Linux was almost a contradiction. Nowadays, every Wi-Fi router is a user-friendly Linux system, right? Or an Android device for that matter. But at the time, it was really weird. Anyway, we had that and had tunnel vision in it, and we had many business customers using my terrible hand-rolled encryption mesh network to connect their multiple offices together over probably dial-up or ISDN connections. Anyway, sold that company to IBM. I eventually made another thing. It's like, what would be good for VPNing is if you didn't have to install it on both ends of the connection, right? What if an SSH server could be a VPN server? So I made this thing called Shuttle, which is hard to spell. It's SSHUTTLE. And it's a Python program that actually takes a little copy of itself and then SSHs into a remote SSH connection and then drops a copy of itself on the other end to run on a remote Python interpreter, which then sends packets back and forth and intercepts your connection. So on the local end, it's like acts as a VPN running as root, and on the remote end, it reassembles those connections and regenerates the stuff. So it was very helpful for people using jump boxes and stuff. Questionable on the security point of view. It's declined in popularity now, partly because Tailscale is so popular. It still remains popular in the sort of, shall we say, hacker community, because they use it as an excellent way to, once they've got any way into a system, now they can use SSH to expand that to all the other ways into a system. So slightly embarrassing, but also, I don't know, if hackers like it, it must not be too bad, technology-wise. And it also has, you might be reminded of the original Morris worm when you think about Shuttle, because it works in much the same way, except interpreters is a lot easier than having to actually compile a C program and stuff. Wait, where did I go from there? Oh yeah, I wrote, when I was at Google, working at Google Fiber, I wrote another VPN called Frobnicast, which is short for Frobnicated Multicast. It's a long story, but it was my first attempt to do NAT traversal, because we had people at home who was trying to connect to a machine behind our firewall in our development lab. And so we had to do double NAT traversal, and I found a way to do that. And that's where we ran into the birthday attack and implemented the first version of the birthday attack in NAT traversal, in my arsenal. And then eventually I left Google. And so Tailscale was the culmination of many, many, many years of slightly misguided attempts at VPNs. And I think I finally got it this time. Or I think what's the meme is we've done this many times and we've become exceedingly efficient at it. I feel like I can write VPNs pretty quick now.
Yeah, I think we've been talking. I mean, this has been fascinating, by the way. But we've talked a lot about, we got into some of the details, but just for the audience, at a high level, a lot of VPNs today are still largely hub and spoke. I suppose historically for air quotes, ease of use, ease to upgrade, or ease of management and policies or something or another. But Tailscale went a different direction than your, 2 concentrators per data center and all your connections coming back in, yada, yada, yada. So Tailscale's full mesh, every device can talk directly to every other device. Okay, can you walk us through just is CEO, I guess the right way to frame this question would be, what is the difference, or what is different, I guess, about Tailscale and traditional VPNs, and why should technical practitioners care?
Sure. So I think the neat thing about Tailscale is our separation of the control plane and the data plane. So when you talk about it being full mesh and peer-to-peer, that's the data plane. Every device can talk directly to every other device, even if they're both behind different firewalls, even if there's no ports open, etc., by doing a series of interesting tricks. And so you can have tens of thousands of nodes, all with possible connections to each other that just come up and go down instantaneously, depending what needs to talk to what at what time. The coordination part of that, which we call the control plane, is a centralized system. And that's what makes it a SaaS product. We run the coordination server for you. And I like this hybrid of distributed system and control system. We've thought very carefully about which parts should be centralized and which parts should not. A business or even a person with a home lab, you want some kind of control over who's allowed in and who's not allowed in. And that central control is where you put your policy, where you say, like, I want, if you're a company, you can say people in engineering should be allowed to access servers in production or servers in the development cluster or whatever. And then once you've made all those rules, you send them all down to the devices and you tell the devices, okay, I have information about all the devices that have registered. Here's all their IP addresses. Here's all their public keys. Here's who you should talk to. And here's who you shouldn't talk to. Right. And then they sort out the rest in the data plane. If you go too far in the distributed direction, you basically always end up at like blockchain crap. No offense to blockchain. Well, no offense, I guess. Offense to blockchain. It's too distributed. And when you try to make something 100% distributed with no central point, it's virtually impossible to do. Everything you think is fully distributed with no central point ends up having having a hidden central hierarchy somewhere, right? And there's this really great article, which is not on this topic at all, and yet it's exactly on this topic. I'm trying to remember what it's called. Oh no, I've forgotten what it's called. It's like the curse of no hierarchy, but that's not exactly it. Darn. We'll have to look up the title.
Yeah, if you can recall it, what we'll do is we'll just put it in the show notes so folks can read it.
Great. It's such a good article. I can find it for sure. But it just talks about how whenever you think you've eliminated the hierarchy, you've actually just hidden the hierarchy, which is much worse because it makes it very hard to debug. And that's exactly what happens in all these blockchain systems, as well as every other fully distributed system. So by Tailscale, by having this incredibly simple control plane who does this really simple job, makes it possible for the rest of the distributed system to be super reliable. And even if the central control plane goes down for days at a time, the individual nodes don't lose their configuration. The data plane keeps on working. So your dependency on the central part is really weak, but it's non-zero, right? And conversely, if you made the data plane centralized, well, it's a huge single point of failure, latency, throughput, expense, everything else. There's no point.
That was a question I had about the data plane. Is there a central component? Because having the ability to talk through a proxy or some sort of a spoke architecture or supernode architecture, there's a lot of supernode designs out there, solve certain problems. But from what you're saying, it doesn't sound like that's involved in the Tailscale data plane.
So the Tailscale data plane, we do have part of our SaaS product involves essentially supernodes. We call them DERP. So it's sort of self-deprecating, I guess. So the idea is like, hey, I'm trying to connect peer-to-peer. Oh, it didn't work, DERP. I will try this. And so then it gets relayed through one of our relays. The interesting thing about these relays is it knows nothing about your public keys, users, encryption, anything. It just sends your packets. Like it says, you say, I have a packet for public key such and such. And it's like, okay, I'll deliver it if public key such and such happens to show up. And then it picks up the packet and sends it along. And so each of these individual DERP servers does not need to coordinate with any other DERP servers or the coordination system, which makes it an extremely simple distributed system that is very hard to screw up. Now the downside.
Hang on, you just said something really, really important there for the architecture. It's not a proxy that's relaying that. You just described store and forward. You did not describe.
Now it never stores it, so it assumes the other person is already connected. So you connect and just stay connected. Okay, and it will send the packets through. Now, most of the time, those DERP servers are used just to help negotiate these complex NAT traversal connections. So you might send 5 or 6 packets, and then once you've sent those 5 or 6, now you get the direct connection. So it's actually pretty cheap to operate the DERP network. It just always has to be on. And this is where, in a true IPv6 world, we would not have needed that. We could have just used IPv6's abilities to actually talk to devices.
Yeah. So generally speaking, then, in my tailnet, my nodes are talking directly to each other. Is that, are there exceptions to that?
Only if your firewall is like extremely, extremely picky.
Okay.
Interesting. So I guess kind of there's a lot of other topics. We're not going to get to all of them, but moving on to and no conversation is complete without saying something about AI and talking about AI. So I was reading something that I think it was actually a transcript from another conversation, but you sort of talked through how like AI adoption is sort of creating a cyber security Wild West of sorts. But I'm just interested in a few things. First of all, what are you seeing there? And I think this might be a good time to maybe talk through, MCP seems to be the, especially with OAuth 2, available. Like it seems to be the kind of the method of adopting MCP in like a sort of traditional enterprise with security guardrails, etc. But first of all, like what are you seeing happening in the market, and what is Tailscale like? Is Tailscale going to have some sort of MCP server? What is Tailscale's plans with that Series C funding that you have? Is it all going to go to AI, or what?
Well, actually, we are Tailscale. It's funny. We like to say we're in a gold rush sell the shovels, and we are the shovel sellers for the AI industry. Almost every AI company uses Tailscale as its network backbone, and it's just a matter of like word of mouth spreading from one AI company to the next, combined with like Tailscale happens to be especially good at a problem everybody using AI ends up having, which is GPUs are in one place, the rest of your stuff is in another place. Well, suddenly now I have to connect multiple clouds together. No one makes a good solution to that except us. And so right place at the right time, but whatever, that's our AI strategy is continue selling network.
There's several companies that would take umbrance with what you just said, Avery, but okay, we'll let it go.
Yep. Well, yeah, there's a more complicated version of the story, but that's the simple one. Now, I personally think AIs are pretty neat. Of course, they have many flaws. The interesting angle that I've been hearing a lot from people lately, is including our customers, is just everybody, especially engineers, wants to deploy MCP servers all over the place. And this reason for that is really simple. They've got all these AI agents. A lot of companies actually have directives from the executive team or the CEO saying you need to use more AI. And so people are like, all right, I'll pop up some agents and do some stuff. And then the agents are cool to chat with or whatever. But what would be really cool is if the agent had access to all of like companies' private data. And they're like, well, okay, I can do this. And MCP is the protocol for this. I'll just slap this over here. And now my agent can talk to all my company's private data. It is, in many situations, because they can't figure out how to do this on a local network, which is where VPNs come in, they put it on the public internet, and then they will try to put some sort of authentication in front, maybe OAuth or something. And maybe that works, maybe it doesn't. It's notoriously hard to configure OAuth correctly. And now you've got a whole bunch of AI agents talking to your company's private data, and the security team rightly thinks like, hey, how do I monitor any of this? What happens if the AI goes rogue, which they always do, because we have, it's early days. How do I see what it's been doing? How do I stop it from doing things? How do I stop the user from uploading like a ton of our customers' private data to an untrusted AI company, et cetera, et cetera. So the way to do this is that you then deploy a thing called an MCP proxy server. So an MCP proxy server sits between the actual MCP server that you're querying and the agent that's trying to talk to it. And that proxy server can do things like log everything that's happening, filter traffic, control which identity you're using to log into the MCP server, and so on. So you get the security team gets this like one central point of control. There's a bunch of companies selling MCP proxy servers now. That's pretty good. Then you have the problem. It's a problem I call identity delegation. You make a request to the MCP gateway. The MCP gateway now needs to jump to the MCP server, but it's not you anymore. It's the MCP gateway. And so now let's say you have it trying to access Salesforce. It's not accessing the Salesforce as you. It's accessing Salesforce as whatever permission, like service account or whatever you set up this gateway, which is okay, but like you don't get the fine-grained permissions of Salesforce. So now like if you twiddled the gateway the wrong way, Avery has access to the wrong person's Salesforce data, right? Probably still inside the company, but I might get somebody else's leads or whatever. That's no good. Or worst case, it's actually modifying other people's stuff because it has, read-write access. What you'd like to be able to do is instead have this gateway operate as Avery, right? But how does it do that? Well, it's going to have to do this thing, and I can't remember the 3-letter acronym in the OAuth standard that lets you do a token exchange. STS, I think. Right? So it can say like, hey, Avery just contacted me. Can I please have a token on behalf of Avery to access this server as myself? And then the server can say like, oh, yes, it's Avery calling, but he's calling from an AI. So I'm going to restrict his rights a little bit, but generally let you do what Avery's supposed to be able to do. To make a long story short, we have actually implemented this thing, and we have an OAuth server called TS-IDP that you can run on top of Tailscale that does this STS interchange. And it works. You can use your regular company single sign-on to get into Tailscale, and then you use your Tailscale identity with our OAuth server, which has no user interface because it always knows who you are because you're on the Tailscale network, and now every packet has an identity, right? And then so every service you try to contact that knows how to authenticate with TSIDP doesn't need to ask you anything, but does have this ability to delegate your identity properly. And so that combination of features, now you've got connectivity to all the stuff you need, and you've got the ability to delegate it through these proxies onward MCP servers without having to involve a system administrator every single time you want to roll something out. And you've got this ability to watch things. So I'm really excited about this combination of features. And this particular thing is actually all open source on top of Tailscale.
So I was thinking when we started talking about MCP that we were going to be talking about things I could ask my Tailscale environment about via MCP. It was going to be that sort of a conversation. But what you're describing, you built an MCP proxy that gives me an easy, secure way to access other things in my Tailscale environment, but it's not about Tailscale. That's most of the MCP servers I've heard about is they're typically giving you access to something in their environment. That seems to be the point of them. So you can get your AI engaged and sharing all that information in an easy way. You built a tool.
There are actually a couple of open source Tailscale MCP servers that let you query the Tailscale APIs. So you can say like, oh, tell me which nodes join the network between this time, and it like gives you a JSON file or something, and then AI can do whatever it wants. It's sort of neat. But I think it's not as cool as the MCP gateway thing, where it's just like, hey, now it's easy for everybody to deploy all their MCP services in a secure way.
Mm-hmm. And when you said OAuth 2, William, as part of this, it's kind of groaned inwardly inside. Anytime I've had to interact with OAuth 2 as someone who doesn't do coding every day, it's always a bit painful. So something that democratizes that is certainly interesting to me.
It might be painful for those to code every day too. So,
Alex Katz, who does our YouTube channel, has a video about how to deploy TSIDP on Tailscale in 5 minutes. Right, so you roll this thing out, and it's just like none of that pain is in your way anymore. And like the traditional problem with MCP, if you've ever tried to use it, where you have like every time it accesses something, there's yet another click-through pop-up. All that is just eliminated. So it's just this super, super slick experience that, again, you don't have to pay extra for. So it's included in the free Tailscale plan if people want to play with it in their home lab, etc.
Wow, that's awesome. I love it. That free tier. Let me tell you, I've pushed it to the limits. I've done a lot of cool stuff with Tailscale free tier, and the cool thing is like the way that you can set up API keys, set your expirations and everything, include them in CI/CD pipelines to just connect clouds just in a very programmatic and sensible way is pretty awesome. I do have a question based on something you said earlier, which I thought was funny, but I'm going to say something and I want you to give me your reaction. So, zero trust. I want to hear Avery's thoughts on zero trust and the current state of zero trust as far as networking is concerned. What do you think?
All right. Well, I have many answers to that one. One of them is Gartner has a free report you can download about what zero trust means. It's kind of funny. The most recent one that I read says like, okay, 2 years ago, we made a report and we said, nobody really knows what zero trust is. Here's some different definitions. Now it's like, okay, we seem to have gotten some consensus in the security world about what zero trust is, but nobody knows how to implement it. I'm like, all right, well, that's not bad. So that's the Gartner official answer. My answer is different. Zero trust is a term that was coined by a couple of people who wrote a book called Zero Trust. They had modeled a system at Google, they have this thing called BeyondCorp. Nowadays, it used to be just a paper that you couldn't buy. It turns out now you actually can buy BeyondCorp Enterprise from Google Cloud if you want. That is basically the BeyondCorp that they implemented while I worked at Google. And fundamentally, the idea of BeyondCorp is like, well, you have to unpack the name. Corp was the name of their physical network. When you're plugged into the physical network, then you have access to more stuff than when you're not plugged into the physical network. And that's the traditional way a lot of companies did security for a long time, right? Physical network equals trust, based on the idea that there's a locked door on the outside of the building. Everybody tries to get into the building, and if they have a badge scanner, they can get in and everything's okay, right? Wi-Fi came along and kind of immediately obliterated that, but it took us a long time to catch up with the idea that the signal was now leaking outside the walls of the building. But we tried to fix it with encryption Incidentally, the very first version of Wi-Fi encryption was called WEP, Wired Equivalent Privacy, which is a really funny. I feel like the team that invented it was fully aware of how much it sucked, and they tried to sort of like put that into the name so they would be less embarrassed. It's like, well, how private is wired? Like, not very. Oh, so wired equivalent privacy. Anyway, so at one point, Google is like, oh my God, trusting the physical network, it's over. You cannot trust the physical network. Let's use encryption instead. So zero trust is like the outside of Google version of that. All it means is you can't trust the physical network by default. Use encryption instead. And so, my add-on to zero trust is like, look, what they mean is zero trust by default. The problem of all security and all of networking nowadays is, how do you establish trust, right? What you really want is trust. You don't want zero trust. You want trust. How do I get it without just assuming that something is okay, right? And the best way or the only way to do that is to bootstrap trust from something else, right? What you can bootstrap trust from is your company's SSO login, right? That's the thing that fundamentally every company already trusts. And as long as you can do an SSO login, all the rest of your trust in your entire organization can come from that. Maybe 5 hops away, like with TSIDP, right? We've logged into your SSO. That gives you a Tailscale key, that gives you a packet with your identity on it, that can be used to authenticate with TSIDP, that can be used to give a token to the MCP proxy, that can get another token and talk to an MCP server that then talks to something else. But it's all, you can trace it back somewhere. That's what zero trust is, right? And so Tailscale is, by that definition, obviously a zero trust product. And it's kind of nice that it is one that you can actually deploy. But it's not as well known as maybe the concept of zero trust.
Gotcha. Yeah, that makes a lot of sense. I like that definition. It's pragmatic and it's something that you can wrap your head around and understand too, which is good.
Yeah, I'm enjoying the shocked face that Ethan is like.
Why?
You look like you're getting.
It's a pragmatic definition. I think you'd have arguments with a lot of other people in the space about whether that is a complete enough definition.
To it. Some of it, that's where if you read this Gartner report, it's got a long list of things that should come along with it, right?
And they were probably talking about endpoint assessment, repeated endpoint assessment, and related kind of things about where you're at in a given transaction, and that the zero trust also being, just because I trusted you for the last transaction, I'm not trusting you for this one, and then reassessing and so on.
Yeah.
So
yeah, and I try not to talk about all that stuff, partly because it's been layered on by a bunch of vendors who want to sell you things, and it's just like, okay, we've piled all these parts together. Also, Tailscale does do all that stuff. I actually went through an extensive checklist at one point, and a couple of years ago now, and we've checked off all those boxes. We do all those things. I just don't like talking about them because, in my opinion, they're not zero trust, the core definition. But yeah, of course you should do continuous assessment. Of course you should do what used to be called attribute-based access control, right? Your location, your time, anything suspicious. The MDM software is evaluating whether your hard drive is encrypted, right? Whether you installed all your patches. All this stuff can feed into what's called a device posture. And in Tailscale, the device posture is part of your policy. So you can even say for devices that have a crappy posture, they're still allowed to access update server so they can get themselves back in compliance. But they can't access, super secure production service, right? So all that stuff is there, but I just I don't know, I question whether that's true zero trust or not.
Yeah. Yeah, it makes sense. Yeah, if I'm in the office, I of course can have access to all the things I need to access. But if I'm at Howl at the Moon eating cheese fries, then maybe I shouldn't be able to access all the crown jewels.
Maybe not all the crown jewels, but can I look at a dashboard? Probably, right? So you'd love to be able to set a policy based on okay, how much do I trust you on this computer right now? Or I have my laptop, I have my phone, right? I brought my own phone. It's not run by the company. The laptop has the MDM software. Maybe the laptop should be more trusted. Or maybe the laptop is more malware prone and actually my phone should be more trusted. That's up to your IT department, I guess.
Well, William's eating cheese fries, and clearly we don't trust him when he's in that state. He cannot be. He's not in a trusted situation at this moment.
Yeah, well, Tailscale actually has we have a series of blog posts as sort of internal jokes. There's deploying from X. So we've deployed from a train, from an airplane, from a boat. I'm sure you could deploy from a restaurant eating cheese fries if you have the right hardware with the right device posture.
The Tailscale blog is
The feedback,
excellent,
yeah.
by the way. I just wanted to say that. You guys have an educational style blog. Yeah, I mean, yes, it's evangelism for Tailscale on some level, but it's also very well written and thoughtful. Several of the pieces I've taken in, a lot of them make Hacker News, as people just share those articles.
Popular on Hacker News. One of my favorite articles is our April 1st post from this year, where we ported Tailscale to Plan 9. And you'd think that would be a joke, but actually the joke was we actually ported it to Plan 9. And we got the Plan 9 developers to improve the kernel so that Tailscale would run better with Plan 9. And you can read the entire experience on our blog.
Yeah, I'll link it in the show notes. Yeah, April was an exciting month. Didn't you close Series C in April as well? Like 160.
I think so, yeah. I think it may have closed end of March. We announced it in April, something like that. But yeah, we raised 160 million USD. So I guess we'll be around for a while.
And yeah, your valuation, you have over a billion valuation, right? So you're a unicorn. My daughter would be like thrilled. Unicorns. Okay.
Yeah,
She loves
exactly. Well, the joke at our Series B was we were a Canadian unicorn because you could use Canadian dollars. Our valuation is now high enough to be an old-fashioned American unicorn.
That's awesome. Well, I guess we're getting to the top of the hour. So first of all, thank you for coming on. This has been a fascinating conversation. I have rabbit holes I'm going to go down. After this conversation, especially with the whole OSI layer part of the conversation we had earlier was great. It's always interesting just to hear a different way of thinking. Sometimes we get so ingrained in the way that we view things and the way that we see things. And, someone can come along and say something a little bit different. And you're like, okay, that's interesting, send you down a different rabbit hole. But do you have any places on the internet that you're at that you can tell the audience about? Are you out there tweeting, or are you on LinkedIn? Where can people find
I am on LinkedIn. I also have a website of my own called appenware.ca. And you can find me on Blue Sky. I don't use Twitter as much anymore. You can find me as appenware.ca on Blue Sky as well.